We'll start by taking the derivative of this polynomial. For this first term, we've got 12x cubed. The 12 is constant, so that just stays out front. And then we take the derivative of x cubed. We just apply the power rule, which says bring the 3 down and subtract 1 from the exponent. So this is going to become 3x squared. The next term is 8x squared, so the 8 can stay. And then we'll just take the derivative of x squared. Bring that exponent down, subtract 1 from the exponent. So you get 2x to the first. X to the first is just x, so we'll leave it like that. Then we've got 7x. The 7 stays. We take the derivative of x. Now, the exponent on x here is, again, 1, just sort of implicitly. So if you bring that down and then subtract 1, you're left with x to the 0, which is just 1. And one of the rules that we said earlier today is that the derivative of a constant is always just 0. So the derivative of 5 just becomes 0. And now it's just a matter of simplifying a little bit. We've got 12 times 3, which gives us 36x squared. We've got 8 times 2, which gives us 16. And we've got 7 times 1, which is 7. So there's our derivative. Example that's still pretty simple, but the exponents now are just not whole numbers. We'll apply exactly the same procedure that we did before. We've got 6x to the 3.5. The 6 is a constant, so that's going to stay out front. And then we take the derivative of x to the 3.5. Well, that means we've got the exponent that we can bring out front, 3.5. And then we'll have x to the 3.5 minus 1. Then the second term, 10x to the 0.5. The 10 is constant, that stays out front, and then we'll take the derivative of x to the 0.5. So we've got 0.5 out in front, and then the exponent is going to become 0.5 minus 1. So what we're left with is 6 times 3.5, which is 21, and the exponent is 3.5 minus 1, which is 2.5. And then over here we've got 10 times 0.5, which is just 5. And the exponent is negative 0.5. In this example, there are a couple things going on that are slightly different. The first thing you'll probably notice is that the variable is t instead of x. It doesn't really make a difference. The process is still the same. The other thing is that we've got things in the denominator, and a lot of times what's easiest to do is bring them up top by just making the exponents negative. In other words, this 14 over t we'll just rewrite as 14 times t to the negative 1. This 12 over t to the 4th, we'll just rewrite as 12 times t to the negative 4th. And then we've got the square root of 2 on the end. All right, now let's take the derivative. Same thing as before, we're just applying the power rule. The 14 in this first term is constant, so that'll stay. And then we'll take the derivative of t to the negative 1. So the negative 1 comes out front. And then we've got t to the negative 1 minus 1, which is negative 2. The second term, we've got 12, we'll just leave that out front, then take the derivative, which is going to be minus 4 times t to the negative 5. And now the derivative of square root of 2 is just 0, because it's a constant. So we've got plus 0. And now it's just a matter of simplifying a little bit. Combining these terms here, we get minus 14 t to the negative 2. We've got 12 times negative 4, so we'll have minus 48 t to the negative 5. This is a totally okay way to write the answer. If you want to write it in a sort of to look a little bit more similar to how it was given, you can write this first term as 14 over t squared, and this second term is minus 48 over t to the 5th. One more example of this type. We're trying to take the derivative of a function where we're just going to apply the power rule to each of the terms. This first term is x to the negative 1/2. So we bring the exponent down, negative 1/2, and then subtract 1 from the exponent. The second term has the minus 14 out front, so that stays because it's a constant. Then we bring this exponent down. So we've got times minus 3 over 2, and then subtract 1 from the exponent. So we have minus 3/2 minus 1 as our exponent. Simplifying a little bit, this first term becomes minus 1/2 x to the negative 3 over 2. Then over here we've got minus 14 times negative 3/2. So the two minus signs give us a positive, and what we end up with is 21. And then the exponent's minus 3/2 minus 1, so that's going to leave us with minus 5 over 2. One of the important applications of derivatives is being able to find tangent lines to functions at particular values of x. So let's do that for this polynomial, x to the fourth minus 5x cubed plus 2, at x equals 2. The first thing we need, since we're looking for the equation of a line, is the slope. The slope is given to us by the derivative, which in this case we'll notate dy dx. This is a pretty easy one to take. We just use the power rule on each of the terms. The first one's going to become 4x cubed. The second one, we'll leave the minus 5 out front for now, and then take the derivative of x cubed, which is 3x squared. And the derivative of a constant, like 2, is always just 0. We'll simplify this a little bit to get 4x cubed minus 15x squared. Now we want the slope at a particular value, x equals 2, so we'll just plug that in. One of the ways to notate that is to write this little vertical bar after dy dx and write a little x equals 2 at the bottom. It's just a way of specifying what you're plugging in. And we plug 2 into each value of x here. And what we'll end up with is, if you do this arithmetic, minus 28. Alright, so that's going to be our slope. Now we can find the equation of the line if we just have one point, right? Because we want something of the form y equals mx plus b, and we have our m. We just need an x and a y value to plug in, and that'll give us b. The x value is already given, x equals 2. So let's find the y value. The y value is going to come from plugging 2 in to the original function. So we've got x to the fourth, we've got 2 to the fourth in this case, minus 5x cubed, so minus 5 times 2 cubed, plus 2. So you do that arithmetic out and you get negative 22. Alright, now let's plug in all the stuff that we know and see what we get for b. We've got negative 22 for y, we've got minus 28 for m, and we've got positive 2 for x. So we've got minus 22 equals minus 56 plus b. And if you simplify, you'll get that b equals 34. Alright, so the equation of our line becomes negative 28x plus 34. Now if we want to check that we were right, we can graph the function. So here's the graph of x to the fourth minus 5x cubed plus 2. Here's the graph of the line minus 28x plus 34. And you can see if you look at 2 here, that it's tangent to the function at that point. So we were right.